Today we're looking at verifying trig identities again, but this time they're a little bit more challenging. So we're going to start with an easier one, and then they are going to get a bit trickier as we move on. So when I look at this, again, you want to simplify the complex side instead of trying to make the simple side complicated. So I'm going to start on the right-hand side, and I notice that both terms have a tangent squared. So I'm going to start by factoring out that tangent squared. And then what's left is secant squared minus 1. Hopefully some of you recognize that as one of our Pythagorean identities. Secant squared minus 1 equals tangent squared. So we have tangent squared times tangent squared, which is tangent to the fourth. Again, make sure you are writing that x every time you write your trig functions. All right, our next one is quite a bit more complicated. We've got two trig functions being added equaling two trig functions being multiplied. So it might be a little bit complicated to try and figure out how to change it from addition to multiplication. And I'm going to start with the side that's being added. I'm going to start by rewriting tangent and cotangent as sine over cosine and cosine over sine. Because then what I can do once I have fractions is rewrite them with a common denominator in order to add them. So my common denominator will be cosine times sine. So I'll multiply my first fraction by sine over sine, and I'll multiply that second fraction by cosine over cosine. Once I've got that common denominator, I can add my fractions together. So my first numerator is sine squared. My second numerator is cosine squared. And in the denominator, I have sine times cosine. Simplifying my numerator, hopefully you again recognize that as a Pythagorean identity. Sine squared plus cosine squared equals 1. So we have 1 over sine x times cosine x. And then I can split this up again as multiplication. So this equals 1 over sine x times 1 over cosine x, so that's how we transformed our addition into multiplication. And then, of course, the reciprocal of sine is cosecant, and the reciprocal of cosine is secant. Now, you can multiply in any order, so this still does equal secant times cosecant. Third example looks, again, a little bit more complicated. Both sides on this one look complex. I'm going to start by trying to change the denominator on the right-hand side of the equation into a single term so that I can split that up, kind of like what I did on that last one. The way that we get that as a single term is we're going to multiply by the conjugate. We saw this when we had imaginary numbers, and we've seen it when we were rationalizing denominators with radicals. So we're going to do the same thing with our trig function. I'm going to multiply by 1 plus sine of y over 1 plus sine of y. And what happens in the denominator, I'm going to leave the numerator in factored form until I determine whether or not I want to distribute. In the denominator, remember when you multiply conjugates, you multiply your first term, so 1 times 1 gives me 1. But when you multiply those inside terms, we get positive sine y minus sine y, which will cancel, and negative sine times positive sine gives us negative sine squared. Again, hopefully you recognize that as a Pythagorean identity. Sine squared plus cosine squared equals 1. So if we were going to rearrange that, our denominator equals cosine squared. And this is why I left it in factored form, because now we can simplify that cosine out of the numerator with one of the cosines in the denominator. So I'm going to do that. I'm going to cancel my cosine in the numerator with one of the cosines that I have in the denominator. So now I've got 1 plus the sine of y all over the cosine of y. So I'm going to split this up. Now that I have a single term in the denominator, you may remember from Algebra 1, we call it the butterfly method. We're going to divide each term by the cosine. So 1 over cosine y plus sine over cosine. 1 over cosine, the reciprocal of cosine is secant, and sine over cosine is tangent, which is what we started with. All right, the last one, this time both sides of our equation are complicated, so we're going to simplify both sides at the same time. So I'm going to start with the left-hand side, and this is very similar to the last one. I'm going to multiply by the conjugate to get a single term in my denominator. So I'm going to multiply by 1 minus cosecant over 1 minus cosecant. On the right-hand side, I'm just going to do the butterfly method. I've already got this with a single term in the denominator, so I'm going to split it up. All right, so starting on the left-hand side, multiplying. Again, I'm going to keep that cotangent squared factored out in case I can cancel it with something in the denominator. All over, foiling again, we have 1 plus cosecant minus cosecant squared. Remember that plus cosecant minus cosecant canceled. On the right-hand side, dividing that up, I have 1 over sine of x minus sine over sine. Back to the left-hand side, that denominator is one of our Pythagorean identities. 1 plus cotangent squared equals cosecant squared. So when we rearrange this one, it actually equals the negative cotangent. So in my numerator, I've still got, it actually equals negative cotangent squared in the denominator. So in the numerator, I have positive cotangent squared, and in the denominator, I have negative cotangent squared. Over on the right-hand side, the reciprocal of sine is cosecant, and sine over sine is 1. So now the right-hand side is as simplified as it's going to be. I'm going to throw that c in there for cosecant. So I'm going to finish simplifying the left-hand side. Of course, my cotangents cancel, so I have the opposite of 1 minus cosecant x, which is the opposite of what I have on the other side. So when I distribute that negative on my left-hand side, and if I wanted to, I could switch those around because you can add in any order, but I'm sure at this point you can see that they are equal. Here's your you-try question. The right-hand side is the one that's complex, so you're going to want to try and simplify the right-hand side of the equation so that it equals the left-hand side.